So let's talk about just-in-time. Just-in-time synchronizes production with customer demands. So that means that products should be directly supplied to the right place and the right quality and for sure quantity at the right time. The implementation of just-in-time is a combination of three key elements. So it's pull, it's flow, and it's TACT. Pull means that customer demand triggers production to be pulled through the system. Material is replenished based on consumption only. There is no production in advance and stock is limited. So for example, there are pull systems where stock is limited by defined space for products. In a pull system, each process step informs the previous process steps of its needs. This reduces dramatically inventory, so that means a reduction of raw material, work in progress, and final products. And the result is for sure a reduction of lead time as well. Pull can be implemented by applying the Kanban principle. A Kanban is a signal telling the supplier or the supplying process to produce and deliver a defined quantity of products. Originally, the Kanban was a label containing information on the production batch, like the item reference, its origin and destination, references of upstream and downstream processes, and the position in the manufacturing process. In addition to that, there were also sometimes information like the quantity of products and for sure the number of Kanban cards. Yeah. Do you know why the number of Kanban cards is important? The thing is that people exactly wanted to know how much inventory in the whole process is. Yeah? And what the Japanese like to do is to remove some of the Kanban cards to remove inventory and see what happens if the process still works. And if it still works, perfect. Then they've reduced inventory and have a significant impact also on lead time. The Kanban helps to adapt production to consumption. What is consumed is replaced. When the whole batch has been consumed, the Kanban goes back to the upstream part of the production process. There is one easy example for a Kanban. Yeah? It's called two-bin system or two-bin Kanban. So you need to imagine you have two bins. Yeah? At the beginning, both of them are full. Yeah? Now I take something away, so it means I have an empty one and a full one. And the empty bin is a signal for the replenishment product to start to produce and replenish the product. Yeah? That's an easy thing. There's another nice example. Do you know McDonald's? For sure you do. So how many hamburgers do they have? Have you seen it? Yeah. There's always a certain amount of hamburgers available. As soon as one of the burgers is taken off the shelf, it must be replaced from the kitchen. So that's the easiest form of a Kanban. The second important thing is flow. Flow focuses on smoothing workload at workstation and in between. So the goal is to have an equal workload at each station. Yeah? Sometimes if you walk to different companies and you see people working, some of the workers, they work harder than the others in production. Do you think it's good? No, it's not. Yeah? And we want to level that. Ideally, between all those operators or stations, there are no buffers of inventory in between. So that means that the small size of batches is crucial to minimize buffers. The ultimate objective is to reach a one-piece flow. So that means that there's no buffers between the stations and that just one item is moved from one station to the other one at the same time. So in total, the batch size is 1. For example, in a factory for electronic components, you have to imagine there are 3 employees. Employee A puts the CPU in the casing, employee B who will attach it properly, and employee C who closes the casing. Instead of having lots of semi-assembled projects at each of the steps, each employee is working on one item at a time. After he finishes his work, he passes it to the next employee. In a one-piece flow, it's necessary that the materials always move forward. That's something you need to remember. So whenever you have the chance to visit a Toyota plant, look at the material flow. It's perfect. It's a perfect example. You should note that flow requires all processes and logistics to be linked, which means that all work processes need to be harmonized. Ideally, there is a clear TACT between each of the production steps. TACT means to harmonize the system speed and to synchronize it with customer demand. So the customer is always the trigger point. Now imagine you have a sandwich shop, yeah? And there are about 30 customers entering your shop per hour. So that means if you want to calculate the TACT, you need to take 60 minutes divided by 30 customers. This gives you a TACT time, a required TACT time of 2 minutes. So that means your sandwich making process should produce one sandwich every 2 minutes. However, now the situation is you now produce one every 6 minutes. So the result is your customers will have to wait. Do you like the situation? No. So we need to change that. But how do we do that? So first thing, you need to measure the cycle time. That is the time for all activities at each of the steps of the process. In this sandwich making process, there are currently 4 employees and 3 workstations. Workstation A, we have 1 employee, and this guy, he needs 2 minutes to do his job. You have workstation B, there's another employee who needs 4 minutes to do his job, and you have workstation C. So there are 2 people, and they need together just 1 minute to do their job. Do you see already the issue? Well, workstation B, that's the bottleneck. Yeah. So that means finally, that's the reason why your customers, they have to wait. Because the whole value stream cannot work according to the required TACT time of 2 minutes. So that means in addition to that, in front of B, you will find a lot of sandwiches waiting. But that's something we need to remember anyhow. So whenever you see a lot of inventory in front of a process compared to the others, it's a typical sign for a bottleneck. It is obvious that there is a redesign needed. Yeah? So important, remember the TACT time. We need 2 minutes. So what do we do now? Let's start to think through. Workstation A is fine. So because it works according to TACT. How about workstation B? It's too slow, right? So workstation B needs an additional employee to cut workload and process time by half in order to work according to TACT. 2 minutes. And you have workstation C, which is way too fast. So that means what you can do, you can reallocate the additional employee to workstation B. After that, C works according to TACT. So it means according to the 2 minutes. Now, the result is that your customer is happy because, the customer doesn't need to wait anymore and is served fast. Yeah, so that means in total, the sandwich production, the whole value stream, it works according to customer demand. The process of eliminating bottlenecks is also called debottlenecking. Yeah, that's something you might want to remember. And it's very, very critical to the whole just-in-time approach. To conclude, just-in-time avoids inventories and ensures that customers are delivered with reliability by applying pull, flow, and TACT.